See, now laws of reflection. So you know that whenever light strikes a surface, so it is you taken as to be as a surface. When light strikes a surface at the point of incidence, so you make a normal. At the point of incidence, you make a normal, and it is you can take as to be as incident ray, and some part of light ray or partial complete light ray will be reflected back into the same medium. That phenomenon you can take next to be as a reflection, and this light ray you can take next to be as a reflected ray, incident ray, normal, reflected ray, and it is point of contact of light ray. Incident ray makes an angle with normal, you can take an angle of incidence. Reflected ray makes an angle with normal, you can take an angle of reflection. Law of reflection point of view, first one, incident ray, normal, reflected ray. Incident ray, normal, reflected ray to the reflecting surface, at the point of incidence. All lie in the same plane. Lie in the same plane. And second one is angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection, whatever it may be the surface. For example, if you take in convex surface, so whenever light will be incident at this surface, at this point we need to make a normal. So normals are passes through center of curvatures, then it is you taken as a normal, and it will be reflected back into the same medium. Incident ray makes an angle with normal is angle of incidence. Reflected ray makes an angle with normal, you can take an angle of reflection. Then at any instant, angle of incidence equal to angle of reflection. That is the law of reflection. Next, Fermat principle of least time. According to this one, the path of light ray between any 2 points is the path along which the time taken is minimum. So the time taken is minimum. For example, if you take in two different points A and B, so consider a certain amount of paths like this, like this, and like this, and speed of light is remains constant in a given medium. Speed of light you can take in C, that equal to 3 into 10 to the power of 8 meter per second. If you are considered it is a air medium, then so here you can take in distance d, and here you can take in distance d2, and here you can take as well as a distance d3, and here time taken to reach the point, to reach the light from A to B, you can take in d1 distance divided by c, and here time d1 divided by c, and here time d2 divided by c, and here time d3 divided by c. And in this all the times, which time is least, light chooses the path. Definitely the basic property of light will be traveling in a straight line path, therefore light will be chooses a path which takes least time, or which takes a minimum time. That is the basic principle of Fermat principle. Laws of reflection using Fermat principle. See, if you take in it is your surface, and here object will be there, the object height from the surface you can take as to be as A. From the object, a light ray will be incident on the surface, and it is reaches to the observer. It is reaches to the observer like this in this path, and observer is at a height from B from the surface. Let us you can take as well as it is a mirror or surface, and here we need to make as to be as a normal. That is, incident ray makes an angle with normal, you can take an angle of incidence, and reflected ray makes an angle with normal, you can take an angle of reflection. And the point of incidence from the object foot you can take at a distance x. A distance between observer and object you can take as a distance d. Then the distance between observer and the point of contact, you can take as as a d minus x. Already we know that the speed of light in a given medium or in a air medium, speed of light you can take as a c. Now you can see distance between object to point of contact, you can take an under root a square plus x square, and distance between point of contact to observer, you can take an under root b square plus d minus x whole square. Now time taken to reach from object to point of contact, time taken from object to point of contact, that is distance divided by distance under root a square plus x square divided by speed of light, and time taken to reach from point of contact to observer, that is we can take in distance is under root b square plus d minus x whole square divided by b square plus d minus x whole square divided by c. See here, total time traveled by the light, that equal to t equal to time to reach from object to point of contact plus time taken from contact point of contact to observer. Now you can take in this value under root a square plus x square divided by c plus under root b square plus d minus x whole square divided by c. According to Fermat, time is minimum. So we already know the light ray chooses the path which takes minimum time. So according to Fermat, t will be minimum, and here t is a function of x. Hence dt by dx that must equal to 0. dt by dx that must equal to 0. If you differentiate this one, so dt by dx that equal to 1 by c is a constant, so d by dx of under root a square plus x square plus 1 by c times of under root of b square plus d minus x whole square. Now if you differentiate this one, 1 by c equal to 0, that equal to 1 by 2 root x a square plus x square into 2x, differentiation of x square taken as 2x, plus 1 by 2 root of b square plus d minus x whole square into 2 times of d minus x into minus 1. Why? Because again we need to differentiate inner function. So here you got 2 and 2 get cancelled, so x divided by under root x square plus a square that must equal to d minus x divided by under root, here also 2 get cancelled, under root b square plus d minus x whole square. From the diagram, x divided by under root x square plus a square, if you take in as base, it is the angle of incidence I na, therefore it is also angle of incidence I. X divided by under root a square plus x square na, this value belongs to sine I. Sine I, that must equal to, if you take in it is r, then it is also angle is r. For the r, d minus x divided by under root b square plus d minus x whole square is nothing but a sine r. So sine get cancelled, hence we got angle of incidence that must equal to angle of reflection. That is the basic law of reflection. Vector form of law of reflection. So to understand this one, first you can take in it is your surface, and it is incident light ray, it is point of contact, and here you can make a normal direction you can take in n cap, incident ray direction you can take in I cap, and at the point of contact light will be reflected in this direction, therefore r cap is the direction of reflecting angle. So already we know that I cap, magnitude of I cap, magnitude of n cap, or magnitude of r cap, that must equal to 1. Why? Because it is a directional unit vectors. Now if you take an angle of incidence is theta, and angle of reflection is also you can take as a theta. If there is no surface over here na, light ray will be moving in this direction. So then if it is angle of theta na, and it is also we need to consider as theta, and it is your minus n cap, and it is your I cap. Angle between minus n cap to I cap also you can take next to as a theta. From this you can take in along the surface tangential direction and normal direction. Along the surface tangential direction and normal direction. So based on the reference directions normal as well as tangent. Now you can take in I cap. So I cap is in this direction, therefore minus n cap times of cos theta plus t cap times of sine theta. Resolve the I cap into normal as well as tangent. Similarly, r cap you can take. So r cap is nothing but n cap cos theta plus t cap sine theta. N cap cos theta or t cap sine theta. Now you can subtract r cap and I cap. So take these equations. So hence you can take in r cap minus I cap. What do you got now? So here negative sign will come and these two get cancelled. So 2 n cap times of cos theta. So hence r cap equal to I cap. So let us you can take in this equation number 1 and this equation number 2. It is the equation number 2 minus equation number 1. Therefore r cap equal to I cap times of plus 2 n cap into cos theta. And from this equation I cap and n cap is the basic terms we need to calculate cos theta. So now you can take in I cap dot of minus n cap, that is you can take so magnitude of I and magnitude of n times of cos theta. Therefore so I cap dot n cap you can take in minus cos theta, substituted over here. You got r cap equal to I cap plus 2 n cap times of cos theta you can take in minus I cap dot n cap. So final answer you got r cap equal to I cap minus 2 times of I cap dot n cap into n cap. So it is your r cap. It is the vector form of law of reflection. Next, angle of deviation. So here to understand this one, just you can take in it is your plane surface and light will be incident on this plane surface like this. If there is no surface now, light ray will be traveling in a straight line path, there is no doubt. It will be moving in this path. Because of presence of the surface now, light ray will be reflected back into the same medium, causes a reflection. At the point of contact we need to make a normal, and it is you can take an angle of incidence, then definitely it is you can take an angle of reflection. Already we know that angle of incidence is equal to angle of reflection. So it is the incident light ray direction and it is the final light ray direction. The angle suffered by the incident ray due to the reflection you can take an angle of deviation. Angle of deviation, simple term, it is angle between initial direction of incident ray and the final direction of reflected ray. Angle between the initial direction of incident ray, and the final direction of reflected ray, Now if you are taken angle of incidence plus angle of reflection plus deviation, that is a straight line. So from the diagram, angle of deviation plus angle of incidence, angle of reflection plus angle of incidence, that is a straight line, that equal to take next as a 180 degree. Therefore deviation according to angle of incidence equal to angle of reflection, you can take in 2 times of angle of incidence, that must equal to 180, or deviation equal to so 180 minus 2 times of angle of incidence, or you can take in deviation equal to pi minus 2 times of angle of incidence, or deviation equal to pi minus 2 times of angle of reflection. If you know angle of incidence or angle of reflection, then deviation is pi minus 2 times of angle of incidence or pi minus 2 times of angle of reflection. Or one more formula also we need to take in terms of glancing angle of incidence. The incident ray makes an angle with the surface, you can take in glancing angle of incidence, and reflected ray makes an angle with the surface, you can take in glancing angle of reflection. See, glancing angle of incidence you can take in pi by 2 minus angle of incidence. Similarly, glancing angle of reflection also you can take pi by 2 minus angle of reflection. You can take in this formula, that is 2 if you are common out na, so pi minus 2 times of angle of incidence. Okay, we'll see after that in terms of glancing angles. From this diagram only you can take 2 times of angle of incidence is nothing but pi minus 2 times of angle of incidence, and 2 times of glancing angle of reflection, that is pi minus 2 times of angle of reflection. And here you can take in pi minus 2 times of angle of incidence. You can take directly 2 times of glancing angle of incidence, or deviation rho equal to 2 times of glancing angle of reflection. Like this, in terms of glancing angles or in terms of angle of incidences, we need to represent the angle of deviation. Now you can see the graph between deviation versus angle of incidence. So angle of incidence versus deviation, you can know that the deviation is nothing but pi minus 2 times of angle of incidence. If angle of incidence equal to 0, therefore you got a maximum deviation, that is pi. And angle of incidence equal to 90 degrees. And angle of incidence equal to 90 degrees, that is pi by 2 radians, then deviation will be 0. So hence if you draw a straight line, why? Because angle of incidence is in terms of minus 2i times of I. Compare this equation with y equal to minus mx plus c. Hence it is a straight line which intersect the x-axis at pi by 2 and y-axis at pi. So here you can take, so deviation will be maximum. Deviation will be maximum for normal incidence. For normal incidence, so means angle of incidence equal to 0, and the deviation is minimum. So deviation is minimum for grazing incidence. So grazing incidence means angle of incidence, grazing incidence. So grazing incidence means angle of incidence equal to 90. Incidence equal to grazing incidence means angle of incidence equal to 90. So in case of multiple reflections, so if you taken multiple reflections, so multiple reflections point of view, deviation how we need to take in the, so total deviation we need to go with the algebraic sum of individual deviations. Algebraic sum of individual deviations. Like this, the deviation concept we need to understand with the help of diagrams.